Welcome to Ask and Learn.
So we have a square computer chip and its dimensions are x by x, and we want to find its rate of change, the rate of change of the area at the time or the moment when the side length is 15. So first of all, the area of the square would be x squared. And then we would differentiate that to get the derivative, the rate of change, and that would be 2x. So then a prime of 15 would be 2 times 15, so that would be 30. And the units on that, so the units on area would be square millimeters, and the units on side length would be millimeters. So what that's telling us is that at this moment, there would be a 30 millimeter change in area for every 1 millimeter change in the side length. We could take a look at an example. If the side length was 15, the area would be 15 squared, which is 225. And if the side length was 16, the area would be 256. That would be 16 squared. And those are off by what, 31? So that's fairly close to the 30 that was described as the rate of change. Okay, so for part B, so we have our square with side lengths of x. We just found the rate of change was 2x, and the perimeter would be the sum of all the side lengths, and that would be 4x. So the rate of change of the area is half the perimeter. Now what we can do to kind of analyze this geometrically is imagine that we have our square, but that it grows on each side by an increment of delta x. So the area of the new square is x plus delta x quantity squared. And the area of the old square was just x squared. So what's the change in area? The change in area is the area of the new square minus the area of the old square. And that would be x plus delta x quantity squared minus x squared. Let's go ahead and work this out algebraically. We're going to have to use the FOIL process, and we get x squared plus 2x delta x plus delta x squared. And then we have minus x squared from subtracting the area of the old one. Notice that we can cancel the x squared and the minus x squared. And so what we have is 2x delta x plus delta x squared, which is the change in area. So suppose we want to know the change in area over the change in x. Suppose we want to know delta A over delta x. So let's go ahead and factor a delta x out of delta A. And we have delta x times the quantity 2x plus delta x over delta x. Notice that we can cancel the delta x on the top and the bottom. And what we're saying is that roughly the change in area with respect to x is 2x plus delta x. And if delta x is very small, then it's approximately 2 times x, half the perimeter. So if you were interested in approximating a change in area for a very small delta x, you could approximate it by just taking 2 times x, or half the perimeter.